Welcome back to the channel. It's a pleasure to have you here again for another video. This is Pentomatics, your complete online school of mathematics. Here we break down mathematics and make it easy and as simple as possible for you to understand. You're welcome. I'm Pendulum. I'm your tutor on this channel, and we're still looking at indices, logarithms, and sorts. Alright, so we are still continuing on this topic. Today we'll be looking at simplification of logarithms part 2. So we have some longer logarithm problems. You can see that these are combination of two and more logarithms. Alright, so if you're new to the channel, please consider subscribing to the channel and turn on our notifications, ring the bell so that whenever we have a new video up, you'll be notified to come and watch and learn. Alright, so we'll look at these three examples, and this should help you understand how to evaluate questions like this even without tables. Alright, so as we go on, if your video is helpful, do well to like the video, drop your thoughts in the comments so that I know what you think about the video, and don't forget to share this video to your friends, to your status, to your colleagues, to your children. Share it to whoever you know will need it. Alright, now I told you something in the last video. If you've not watched the part 1, it will help you if you watch it so that you can understand what we are doing here. I told you that any operation you're doing on logarithm, basically there are two things you need to remember. Number one, the relationship between indices and logarithm, how to convert from log to indices. It will help you, especially when you have a single indices. For example, if you're asked to resolve log 81 base 3, for instance, if you have to solve something like this, and let's say you have to solve something like this, alright, there are two ways to actually solve it, but one of the ways is converting this to indices and getting your answer. Okay, we did that in the last video, part 1. So in this video, we'll be applying the laws of indices. Okay, and I also made a video that covered the 7 laws of indices, so you should also watch it. It's up on the channel here. Now let's look at these questions one by one. First, we have 2 log 3 base 3. Now first of all, when you have a question like this, let's just go direct. One of the first things to do, remember from the power law, if you have log a b p, you can bring this back and the p will be here. Remember that your p can come back. That's the power law. Alright, so if the p can come back without changing anything, it also implies that if there's a number here in front of a logarithm, the number can also be taken up to become a power without changing anything. So what that means is that I can write this as log 3, these two will go up and become raised to power 2, plus log 6 base 3 minus log 2 base 3. So this is the first thing you do, write it in this way. Now, once you've done this, you look at the 3 logs you are given. You can see that this is log base 3, log base 3, and log base 3. If they have the same base, then your question is quite easy to solve. All you do here, remember, is take one of the bases, log 3, since they are all the same, and then you remember that we said from the addition law of logarithms, when two similar logarithms are added that have the same base, they are going to multiply these numbers in front of it. Alright, so when it's addition, you multiply the numbers in front. When it's subtraction, you divide. So what that tells us is that since they are the same, log 3, log 3, log 3, I can take log 3, then I open a bracket. I'm going to have here 3 square times 6. Alright, and then because it is minus is division, divided by 2. Alright, so this is what I'm going to have. 3 square plus is times 6 minus is divided by 2, and this will give me log 3 square is 9. 9 times 6 is 54. So I have log 54 over 2. Everything is still base 3. and log 54 over 2 is 54 divided by 2 should be 27 base 3. Okay, so I have log 27 base 3. Now 27 base 3 can be rewritten as this. 27 is 3 raised to power 3. Okay, so I can write 27 as 3 raised to power 3. And of course, this 3 here can come back. So this will give me 3. This 3 will come back. Log 3 base 3. And you also know that any logarithm of a number to the same base is 1. So log 3 base 3 is 1, meaning that my answer here is 3. Alright, so this is not difficult at all. All you should remember is from here, just pick one of the logarithms, open your bracket, 3 squared plus is times 6 minus is division divided by 2. Now if you resolve this bracket, 9 times 6 is 54 over 2. If you divide 54 over 2, you get 27. Now you put 27 in the same base as this number down here. So 27 is 3 cube. So that's what we did here. So we wrote 27 as 3 raised to the power 3, all in base 3. From the power law, we can bring this one back. So we now have this 3 comes to the back. 3 log 3 3. And remember that the logarithm of any number to the same base, log 3 3 for instance, is 1. So our answer here is what? 3 times 1, which is 3. So you can see that these things are actually not difficult. It's just knowing what to do. The same thing here, you can see that this log 5, log 5, log 5. Alright, so in this case, because everything is log 5, we'll just take one of the logs. So log 5. Now this is 3 over 5. Remember, plus is times 15 over 2. Okay, sorry, I didn't see this. So first of all, we'll rewrite this, we'll take this power up. So we have log 3 over 5 base 2, base 5. Then this 3 will go up, plus log 15 over 2 base 5 all raised to the power 3 minus log 81 over 8 base 5. Alright, so from here we just take one of the 5. We have 3 over 5 times 15 over 2 cube times 15 over 2 cube, and the minus is divided by 81 over 8 divided by this. Alright, so if we evaluate this, we're going to get I think in a way we're going to get 3 over 5 times 15 times 15 is 225. So 225 times 15, 5, 10, 12, 10, 11, 5, 2, 2. So this will give you 3, 3, 7, 5. 2 cube is 8. Then this division, because there's a fraction under it, we can change it to times, and then we'll invert this one. So that will be 8 over 81. Okay, I hope you're following what I'm doing. It's actually quite simple. Alright, so from here you can cancel out some things, like 8 should be able to cancel out 8. 3 here 1, 3 here should be 27. Then 5 here 1, 5 into 33, 6 remainder 3, 5 here 7 remainder 2, 5 here 5. So we have log 675 up here all over 27 base 5. Now if you divide this, I think you're going to get log 675 divided by 25 divided by 27, sorry, should give you 25 base 5. If you divide this, you can confirm it with your calculator, but I think that's what it will give you. Alright. Now, log 25 can be written as log 5 square base 5. Always try to put this as a power of the base. Alright, so if you have 25, you know that you put it in 5. Alright, always try to put the number on top here, express it as a power of the base so that you can bring this back. I can bring these two back and we have 2 log 5 5. I can bring these two back. I have 2 log 5 5 and log 5 5 is 1. Log 5 5 is 1. So I can get 2 as my answer there. So you can see that it's not difficult. You just have to be careful when you're working. Alright. And then finally number 3. Now we have, okay, let me write out the equation. Log 10 root 35 minus log 10 root 2, and this plus minus log 10 root 7. Alright, so know that it must not always be plus first before minus, so it can be minus before plus. It doesn't matter. If it's minus before plus, then you have to be this one, root 35, divided by root 2, if it's plus here, times root 7. So take note, it must not always be plus and minus. It may be plus plus. If it's plus here and plus here, what it simply means is root 35 times root 2 times root 7 if it's plus or true. If it's minus or true, root 35 divided by root 2 divided by root 7. Alright, so if it's minus before plus, this divided by this times this. If this is minus and this is plus, but because this one now is plus and minus, it will now be this times this divided by root 7. So we can take one of the root 10 and then we have root 35 plus is times root 2 minus is divided by root 7. Alright, and this will give us log 10. Root 35 times root 2 is root 70 all over root 7, which you know we can write as root 70 over 7. Alright, we can extend the square root to cover everything. We can extend the square root to cover everything. And then this will give us log 70 over 10. So 10. 70 divided by 7 is 10. Base 10. Alright, now if you get here, what can you do? Well, I can express root 10 as 10 raised to the power half. Remember, square root is half, base 10. Now this half can come to the back. So I'm going to have 1 over 2 log 10 10, and the log of any number to the same base is 1. So my answer is what? So I decided to add one more question so that we'll try it out. So we are asked to solve log 30 over 16 base 10 minus 2 log 5 over 9 base 10 plus log 400 over 243 base 10. Now first thing, let's take these two up. First thing we do, so we have log 30 over 16 base 10 minus log 5 over 9 base 10, 5 over 9 then raised to power 2. That's what this means. Plus log 400 over 243 base 10. Now I want to point something out. You may see some logarithms like this where no base is indicated. Alright, so you may see a question that is just written like this. Now, if you see a question like this, you may be wondering what base is this? You should know that base 10 is the natural logarithm of numbers. Alright, just like we did number bases, decimal or base 10 is the natural base. Also a logarithm, base 10 is the natural logarithm. So if you see a logarithm where the particular logarithm is not indicated, that's the base of the logarithm is not indicated, you assume that is in base 10. So in this case, if it's not indicated, we are going to assume that it's in base 10. Alright, so whether they put 10 or they don't put, it is in base 10. If it's in any other base, that base will be stated. Alright, so like this one, you have base 2, base 4. But if there's no base, assume that it's in base 10. Alright, so now that we've done this, what we do next, we'll bring out base 10 since they're in the same base, and then we open our bracket, 30 over 16. Now this is minus that came first this time, which is division. So divided by 5 squared, let's just put it there. 5 squared is 25, 9 squared is 81. Let's just write it out once. Okay, then plus is times 400 over 243. Okay, so just remember, minus is division, plus is times. Now, what again you need to remember here is that when you are solving division and it involves fractions, this one remains like this. Now, this division has to change to multiplication, and when you change this, the number after the fraction after the division sign needs to be inverted. So you need to turn it upside down and it becomes 81 over 25. Then this one remains 400 over 243. Alright, so now we need to start doing some cancellations. Okay, first of all, 25 here is 1, 25 here is I think 16. Yes, 16. 25 to 400 is 16. 16 will cancel out 16. 3 here is 10. 3 here is 8, 1. And then 81 will cancel out 81. So we are left with log 10, 10, which is 1. Alright, so the simple thing we did here is cancellation. If you don't know how to cancel out, you can simply use calculator. Logarithm is actually not difficult. It's not difficult. Just remember your laws. Wherever you see minus, know that you're going to divide. Wherever you see plus, know that you're going to times. Alright. So your assignment is on the board. This is your assignment. You can try it out.